Let's talk about erosion and feedback loops. So erosion is when soil or rock is moved from one place to another, usually moved from the place where it's formed to further downhill. Now, as far as where erosion usually happens, erosion usually happens on steep slopes, fastest, and also on slopes where there's little vegetation. Now, erosion happens everywhere on Earth. It does not matter where it is, but it will occur faster the steeper the slope and the less vegetation there is. And the reason for that is on steeper slopes, water has more power and moves faster, meaning it can pick up bigger and larger rocks. Now, for vegetation, vegetation can help keep soil in place. The roots of a plant can help hold the soil in place, meaning that it can't be washed downhill by rain. So the more plants you have, the slower that erosion will occur. Now, sometimes erosion can happen from spontaneous events like a wildfire. Here's a picture from the Waldo Canyon fire in 2014 in Colorado. And what happened is the wildfire removed all of the trees from the area. And when the trees are removed, not only that, it also created a bunch of ash. Well, you have ash and bare soil with no vegetation. What happens? A lot of erosion will happen. So when people or wildfires remove ground cover or vegetation, they remove the protection from the erosion. And so wildfires can actually lead to faster erosion. Same thing for deforestation. Now, there's ways to prevent this from happening. You could go in and stabilize the soil, or you could replant trees after a wildfire to prevent the flash floods from occurring, but you've got to do it very quickly. Even large rocks can actually be used to prevent ground erosion because the large rocks can stop the water from flowing downhill quickly. Now, erosion doesn't just occur on mountains, it can also occur in valleys or plains. So farms are one of the fastest places on Earth where erosion can occur. Most farms lose about 1 inch of soil every 25 years, or about 1 millimeter per year. So without soil, crops don't grow. The soil, the good, nutritious soil gets blown away or washed away by water. And the next year's crops grow even worse, which leads to more erosion and on and on and on. So that's a feedback loop. Now, this is one of the reasons the Dust Bowl in the United States was so bad, was they had been farming and tilling their soil and just letting the soil blow away every year. Eventually, their soil got so bad that they really couldn't grow crops that well. Now, it didn't help that they were also in a drought either, but with good soil, plants can somewhat weather a short drought. But with bad soil, it just exacerbated the problem and allowed dust to blow everywhere. Now, for mountains, the erosion is pretty straightforward. Is the mountain steep or is it shallow? So steep mountains, more erosion. Shallow mountains, lower erosion. Does it have plants? More plants, less erosion, less plants, more erosion. So mountains can erode as well. The average mountain will erode faster than the average farm. So 1.55 or 1.5 millimeters per year for the Himalayas, which is really fast as far as geologically speaking goes. It is faster than most farms, but there are some farms out there with bad soil management that can erode even faster than the Himalaya mountains. That just shows you the power of bad soil, or at least bad soil management by farmers. But as far as erosion goes, Himalaya is very steep, very low vegetation, very fast erosion. The rocks are going to go right downhill as fast as they can. Now, erosion can be a positive or a negative feedback loop. So here's an example of a negative feedback loop with erosion. Well, no, here's just an example of a negative feedback loop. Let's say you use your paycheck to buy an Xbox. Because you have an Xbox, you buy more games. Because you have more games, you spend more time playing games. If you spend more time playing games, you spend less time working, which means you'll eventually run out of money and cannot buy a new Xbox. Here's an example of a negative feedback loop when it comes to rocks. So here's an example of desert landscape. You have severe erosion in the desert because there's no plants. It's all exposed. And the smaller particles get carried away. The silts, the clays, and the sands get blown away by the wind. When the smaller particles are carried away, you're just left with larger rocks. You can see them right here, these pebbles and cobbles. Well, because they're larger rocks, wind can't pick up those larger rocks and blow them away, so they're stuck in place, and erosion slows down and stops. So for a negative feedback loop, a good rule of thumb is at the end, you did not lead back to what you started with. You have less erosion at the end than you started with in a negative feedback loop. A last example of a negative feedback loop, notice the arrows also do not lead back to themselves. The arrows go and then just stop. So if you have a feedback loop where it's asking, is this positive or negative? And you see the arrows lead to nothing, or they lead to an X, or they don't lead back to the beginning. That will be a negative feedback loop. Now, a positive feedback loop, maybe it's an example from school. A positive feedback loop causes more of itself to happen in the future. So it leads to building up. It builds up itself. Maybe you believe in yourself more. So you do, or you try harder in school. Because you try harder in school, you get better grades, which leads you to believing in yourself more, because obviously you can do better because you did last time. So you do it better the next time. You try even harder, which leads to even better grades, which leads to you believing yourself even more. So that's just an example of a positive feedback loop, but there are more. So erosion tends to be a positive feedback loop. There is quite a few feedback loops out there for erosion. The first example is cutting down the rainforest. So there is lots of reasons to cut down rainforest for people who live in the rainforest. The first one is for people that are loggers. They want the lumber from the trees. Okay. Another type of person that wants the rainforest cut down is farmers. They want the soil that the trees grow in. So after the trees are cut, farmers will move in, they'll plant their crops. Great, but there's a problem. Without all the trees from the rainforest, this topsoil will start to be eroded by wind and water. And after only a few years, the topsoil will be completely gone for the farmer. And they'll have to cut down more rainforest in order to plant their crops again. And you can see the cycle continues. It builds on itself. Every time they cut down rainforest and they farm, then it gets eroded, they cut down more rainforest, then they farm, then it gets eroded, then they cut down more rainforest. And it just continues and continues. Another example of a positive feedback loop would be overgrazing. This happens in near the Sahara Desert, and it's actually why the Sahara Desert is actually growing. So what they have is cattle or sheep or goats. They eat all of the grass in an area. In a dry area, there isn't that much grass to eat, so they eat everything they can get their mouths on. Well, after they eat all the grass, there's no vegetation to prevent erosion, so the soil gets eroded away. When the soil gets eroded away, the new grass that grows in afterwards has a harder time growing. So less of it grows, and then next time the cows or the sheep or the goats come in, there's less plants for them to eat, so they eat it all over again. And then the cycle continues. Then there's more erosion, less plants, more overgrazing, then more erosion, less plant, and it continues, it continues. That would be a positive feedback loop. Reduce soil erosion on slopes. You can actually build rock walls to prevent water and even wind erosion, because most wind erosion happens in the top 3 feet. So most wind can only pick up sand about 3 feet high. After that, it just jumps it down again. So rock walls, depending on how high they are, will actually stop soil erosion. Now, terracing is another way to actually stop erosion. Basically, it turns steep slopes into flat slopes. And steep slopes turning into flat slopes will actually slow erosion down, because flat slopes don't really erode. You can also use water to actually prevent erosion by wind. Crazily enough, it is possible. The water in this picture right here will actually weigh down the soil and keep wind from being able to pick it up. The water will also build a crust in the soil and actually will help the soil to stick to itself to keep it from being picked up by wind. So if you've got a temporary hill of soil and you need to keep it from being blown away, water will do that. You don't want a permanent solution like terracing unless you know you're going to build it permanently.